Welcome back to the Data Analytics tutorial series. Today's focus is data preprocessing, one of the most important stages in any data project. Whether your data comes from a structured or unstructured source, you'll need to prepare it before conducting any analysis. So, let's dive into the different techniques and processes used to get your data analysis ready. Before we start learning, let's get a quick overview of what we will be covering in this video through the contents. Data preprocessing is a crucial step before any analysis or modeling can begin. In this video, we will explore the different techniques used to clean, transform, and prepare data, ensuring that it's ready for analysis. Let's jump right in. Data preprocessing involves converting raw data into a clean, organized format suitable for analysis. This includes handling missing data, transforming data into appropriate formats, and ensuring that it's free from errors. Neglecting this stage can lead to incorrect or biased results in your analysis. Preprocessing your data ensures that it's accurate, relevant, and consistent. It's critical for removing biases, handling outliers, and cleaning up any inconsistencies. Preprocessed data enables your algorithms to produce accurate results, avoiding potential pitfalls caused by unclean data. There are three main steps to preprocessing your data. First, data cleaning addresses errors, missing values, or inaccuracies in the dataset. Second, data transformation modifies the data to fit your analysis requirements. Lastly, data reduction simplifies the dataset without losing important information, ensuring faster processing. Missing data is one of the most common issues in any dataset. Ignoring missing values can skew your results, so you need to address them early in the preprocessing stage. There are several methods for dealing with missing data, such as removing rows with missing values or using statistical measures like mean, median, or mode to fill in the gaps. For numerical data, you can replace missing values with the mean, median, or mode of the dataset. Another method is forward or backward filling, where missing values are filled with preceding or following data points. For more complex cases, predictive modeling techniques can estimate the missing values using algorithms. For categorical data, the most common approach is to replace missing values with the most frequent category. Alternatively, you can introduce a new category to represent missing data or predict missing categories using classification algorithms. Outliers are extreme values that can distort your analysis. They might indicate data errors or represent valid but rare events. Depending on the context, you may remove them or apply transformation techniques like log transformation to reduce their influence on your analysis. Normalization and standardization are two essential techniques for scaling numerical data. Normalization scales your values between a fixed range, usually 0 and 1, while standardization adjusts your data so that it has a mean of 0 and a standard deviation of 1. These techniques are crucial when working with machine learning algorithms, especially for algorithms that rely on distance measurements. For categorical variables, we need to convert them into a numerical format for analysis. Label encoding assigns a unique numeric value to each category, while one-hot encoding creates binary columns for each category, ensuring that machine learning algorithms can properly interpret categorical data. Label encoding is the simplest form of encoding where each category is assigned a unique integer value. However, this method can cause issues with algorithms that interpret larger numbers as having more importance, which is why one-hot encoding is often preferred. One-hot encoding solves the issues of label encoding by converting each category into binary columns. This is the preferred encoding method for most machine learning models because it prevents the model from assuming any ordinal relationship between categories. Feature scaling ensures that all features in your dataset contribute equally to the model. Min-max scaling, as we discussed earlier, normalizes the data between 0 and 1, while standardization adjusts values to have a mean of 0. Robust scaling can also be used to minimize the effects of outliers. And that wraps up our video on data pre-processing techniques. By now, you should understand how to clean, transform, and prepare your data for analysis. In our next video, we'll cover exploratory data analysis, where we'll dig deeper into understanding and visualizing your data. If you found this video helpful, make sure to like, subscribe, and turn on notifications so you don't miss any updates. Thanks for watching, and see you in the next tutorial.